Okay, so looking at these first three examples, again, the first thing you'll need to do is you'll need to isolate the absolute value bars and anything that's inside of it. Okay, so what I mean by that on this first one, if there was anything else on the left side of the equal sign, I would need to get rid of it first. On example 2, we're going to need to get rid of that 3 before we take the steps needed to solve it. But what those are, it's kind of what I just did on that warm-up. I'm going to take 2x plus 1. I'm going to set it equal to 5. And I'm going to set it equal to negative 5. Because 5 and negative 5, those are the only two numbers that when I take the absolute value of them, I'm going to get 5. All right, and then Cam, what? So just on the first one where it's positive 5, what two things do I need to do to solve for x? What do I need to do with that 1? How do I move plus 1 to the other side?
You can take it.
Casey? Subtract 1. And then do what? Yep.
Oh, then it would be 2x equals 4. And
Then
then you would divide it.
divide by 2. Alright, the good thing about this is now whenever we go to the negative 5, the steps are going to be the same. I'm going to subtract 1, divide by 2, and I'll get my other answer. Okay. Going over to example 2. If it is 2 times the square root, 2 times the absolute value, it's not even that. It's 3 times the absolute value, which I think on y'all's notes, is that different? Example 2? Y'all's looks really weird. So rewrite example 2 with what is on the board, or what is on the screen up there. Now, if it is 3 times the absolute value of whatever, how am I going to get rid of that 3? Eden? Divide by 3. So on that one, you should have set x plus 2 equal to 3, and you would have gotten 1, x plus 2 equal to negative 3, and you would have gotten negative 5. If the original problem was this, you don't have to write this down, but if the original problem was that, what would I need to do first? Nope. Move the 4 to the other side. How would I move the 4 to the right? I would add 4. And then I would divide by 3. Which that comes out to some decimal. So make sure that you can isolate that absolute value just like you would isolate x if you're solving for x. Okay, but now it's just the whole absolute value part. So on example 3, Case, what would I need to do on that one first?
Divide by 3 or negative 3.
Divide by negative 3. Now somebody tell me why that should raise a red flag right there. What about that looks weird, Tana?
Absolute values are always positive numbers.
whenever you find the absolute value of something, it should always equal out to a positive number. So, if you get to a point in a problem where you get that right there, or something that looks like it, you are done with the problem. It's no solution. Be careful with that. In the past, I've had plenty of people who will set x plus 1 equal to 3 and x plus 1 equal to negative 3. Going down to these two graphs. So whenever you have absolute value of an equation equal to a number, we can do this on the graph by graphing each individual one. So 2 times the absolute value of x minus 5 minus 4, and then just y equals 2. Whatever is on the left side of the equal sign and whatever is on the right side of the equal sign. You can put this in your calculator and graph it, but I really think absolute value in linear equations, it actually is quicker to do it by hand. Now whenever we get into quadratic and some other functions, those are a little more difficult, but since these are all straight lines, they should be pretty easy. Peyton, net x minus 5, so we need to figure out where our vertex is. Peyton, the x minus 5, which direction is that going to move it? If it's inside, to the right 5, and then the minus 4 is going to move it where? Down 4. So right 5, down 4. There's my vertex. And then, Matthew, what is my slope or my a value on this one? 2. So I'll just go up 2 over 1, up 2 over 1. There's the right side of my absolute value. And then I go back to the vertex and I go up to left 1. The equation y equals 2 is going to look like, what is that line going to look like? Vertical or horizontal? At what y value? So there is that right there. The solutions to the problem, those are going to be the x values of where they cross. So Jade, what are those two x values?
2 and 3. Hold on.
2 and 8. 2 and 8.
Oh.
Yep. Okay, that's all you're looking for. What x values are those? So the 2 and the 8. I want you to attempt example 5 for me. For your vertex, it goes to the left 1. I did have a little confusion here because there was no d value after the absolute value bar. All that means is the vertex doesn't move up and down at all. It's going to go to the left 1, and there's my vertex. My slope or my a value is negative 3, so I'm going to go down 1, left 1. Or sorry, down 3, left 1. And then also down 3, right 1. Okay. And you heard me and Eden talking about it there. So the y equals 9 line is just going to be a horizontal line right there. So if those do not cross, then it is no solution, because the solutions are found where the two graphs will intersect. Sorry, I didn't write in the y1, y2, but your y1 should have been there, and then 9 should have been your y2. To go on with the confusion about there being no d value, if y1 was that, does it move left or right? No, because there's no c value now. Okay, there's not that +1 inside, so it is possible for it not to move left or right, or up and down on some of them. That's fine. You just won't have a c or d value, whichever one goes with that transformation.
And they have this question like example 5. Can they just write no solution, or do you expect them to have that drawing out and the y1 circle?
I want to see an explanation as to why it is no solution. So that is either graphing, or if you noticed, example 5 was the exact same as example 3. 3 we just did it algebraically, 5 we graphed it. So whether you show it one way or the other, it does not matter. But I do need to see an explanation as to why it is no solution. Going to example 6, this is an inequality. So most teachers teach this with shading. Because I'm weird, I like to do things differently, and in my mind save a little bit of time in doing it. I'm going to do a little bit differently. If you like to shade, awesome. If you get the right answers doing it that way, do it that way. It's not going to be wrong or anything. So, graphing this, Jacob, what would my vertex be? -1, -4, right? So left 1 down 4. Tanner, what is my A value?
1. Or 1/2.
1/2. So I'll go up 1, right 2. And up 1, left 2. And Callie, what inequality is that in the equation?
Greater than or equal to.
Greater than or equal to. So, this is the part that I'll do it a little bit differently than some teachers. If it is greater than, common sense would tell you that it is either above or below something. Above. So, instead of going through here and shading this all, okay, and maybe it's because maybe I'm a little obsessed, and if I was to shade this, then any white space would bother me. Maybe that's why I do it the way I do it. But instead of doing that, all I do is I go from the vertex, I draw an arrow going up, and that's just going to tell me all the solutions are on that side of the V. Even if it was one that was reflected, but in the equation it said greater than, I would go to the vertex, I would draw an arrow going up, and that would tell me the solutions would be on that side of the V. So it's got a couple points for us to check. Is the point 6, -3? Right there. Is that a solution? No. Because the arrow is not pointing to the region that is in. -6, 2. Is that a solution? Yes. Because that's on the side of the V that it is pointing to. Is the point 3, negative 2, right there. It's not listed on your paper, so kind of look up here. 3, negative 2, is that a solution? Yes, why? Because it's a solid line, because the inequality is equal to. If our graph looked like this, would that be a solution? No. So make sure that you know a solid line has an equal to underneath it, a dashed line does not. Going to these two word problems down here. I've had students in the past that struggle with these quite a bit, and I think the easiest way to approach these is to step away from the math, be able to kind of, because the problems get kind of a little wordy, kind of decode it and just use common sense, as opposed to, oh, it's an absolute value problem and I got to set up the equation and da 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 da. Okay, kind of step away from the math and just use common sense as to what they're trying to get across here. So on 7 it says a jewelry company manufactures 16-inch bead necklaces. The specifications allow for a difference of half an inch. The function f of x equals the absolute value of x minus 16 represents the acceptable difference in necklace lengths versus the specification. Graph the function on the number line. All this is saying is a company makes a 16-inch necklace. That's the ideal length. But they allow for a half-inch error on either side of it. So, kind of going back to the warm-up, what two values are half units away from 16? 15.5 and 16.5. So the shortest necklace they allow to be made is 15.5. The longest is 16.5. Is it okay if it is 15.8? Yes. Okay, it doesn't have to just be 16 or 15.5 or 16.5. It can be anywhere in that range of 15.5 to 16.5. So whenever you write a statement saying that, it is anywhere from 15.5 to 16.5. So we'll go through this whole thing kind of using Coach Howard's weird common sense approach, and then we'll go back and talk a little bit about the math. So going over to the number line, we'll just label it like this. I'm going to go every 2 increments. I'll count as 0.5. So it's going to go from 15.5 to 16.5. Do I need to have open or closed circles on those? Closed. What does a closed circle mean as opposed to a open circle? It's equal to it. And then you would shade that in. That means that all those links in between those two is acceptable. So going back up, and I think the part that makes this confusing, a big part of it is the equation that is in that. And some people think that is the equation that represents the length of the necklace in a way. And you know, I think that's where people get thrown off. That represents the error that is allowed. So we would set that equal to 0.5 to find the two links that kind of the range that they allow these necklaces to be. So if I was to solve that, I need to set x minus 16 to what two numbers? Positive 0.5 and negative 0.5. On both of them I would add 16. And that will give me the lowest length of necklace and the highest length of necklace. Or longest. Questions on that problem? Let's go down to the next one. This one has a graph. I'll do the graph at the very end. This graph is very hard to read. It's not, I don't want to say it's useless, but there very well may be no use for it on this problem. So, going through this, it says the cereal company fills boxes with cereal that are sold by weight. Each box should contain 32 ounces of cereal. The specifications allow for a difference of half an ounce. The function f of x equals x minus 32 represent the acceptable difference between weight of a box of cereal and the specifications that do, and the specifications, graph the function. So, ideal weight is 32. They allow for half an ounce difference. What is the lightest box they're willing to sell? 31.5. So below this, we're going to put the specifications that, or the weights that do meet those specifications. 31.5. Can it be equal to 31.5 and it be okay? Yes. What is the heaviest box they're willing to sell? 32.5. I'm going to come over here. I am going to use this, but I'm going to use this x-axis as a number line. And you'll kind of, hopefully you'll see why. So, the reason why this graph is so hard, because it's so zoomed out, it would be hard to see all the, where it crosses and all the data that we would need. But 31.5 is about right there, and 32.5 is about right there. So the specifications that meet it is going to be inside of this. Make sure you read what the problem asks. Does it ask for the specifications that do meet? No. So what we really need to look at are these right here. So, how many lines are on that number line? How many? 2. Okay. The number line above on the first example, or on the first word problem, how many lines were on the number line? 1. There was 1 line, so we had 1 statement. There's 2 lines, so you have to have 2 statements, because there's a gap in between. Okay. So this represents all the values that are what? Less than or greater than 31.5? Less than. Do I need to put an equal on that one? No, because remember 31.5 is okay. They can sell that box of cereal. And then you have to have another statement for the 32.5. 2 lines, 2 statements. 1 line, 1 statement. And take note as to how those look. The 1 statement we had looked a little long. These are just 2 small ones. Let's jump back to the number line over here. Are these going to be open or closed circles? Open. Because they are not equal to's. Small details, but that's going to be the difference on a CVA question. One's going to look exactly like that, and the very next one's going to have them filled in. Okay. Questions on this?